Okay, so we're moving on. So the law of syllogism just is another logic idea, and it just means if P then Q and Q then R are true, then if P then R is also true. So what that means is something like this. So if she weighs the same as a duck, then she is made out of wood, and if she is made out of wood, then she is a witch. So we can conclude that if she weighs the same as a duck, so if she weighs the same as a duck, then she is a witch. So ultimately you're cutting out the middle part, the then she is made of wood and if she is made of wood. So if she weighs the same as a duck, then she is a witch. Okay, what you conclude about this following statement? So the stereo is on, and the volume is loud, and if the volume is loud, then the neighbors will complain. So if the stereo is on, then the neighbors will complain. Guys, if you're not getting this, I'll also post this video on my website as well as the filled out notes, so you can go back through and copy them down on my website. Okay, so now we're going to talk about some notation, and we're going to tie these together as we come up with these definitions throughout this unit. So just something that we need to be extremely particular about. So math is a very particular thing, as in the notation is super important, because if you don't have correct notation, you could end up with a very, very wrong answer. So how we write a point. So if this is what a point looks like, we have a dot, it is labeled A. The notation for that point is just A. A line, the definition of a line, is an ongoing collection of points that goes through 2 points. It goes on forever either direction. So if this is the line that goes through the points B and C, the notation to write that line would be the line BC with arrows on the ends going both ways. A line segment means that it has 2 endpoints. There are no arrows, no ongoing line. So this would be the point, or the line segment DE, and it would just have a line on top with endpoints. You're not sure of the points, but no arrows. A ray means that it has one endpoint and then goes on forever in the other direction. So that notation is FG, with your arrow pointing wherever your arrow is pointing away from your ray. So if F is your starting endpoint, then that needs to come first. And then angle, this specific angle right here, as it's written like this, there are 3 different ways to write it. You could write it as angle K or angle K. I usually draw a little dash mark through mine. You can name it as angle JKL or as angle LKJ. Oftentimes you have to use 3 points around the angles because there are more than one angles of K. So if I have another line coming off here that is like H, if I say angle K, I have no idea whether I'm talking about this angle or the entire angle. So make sure that you label it as specifically as possible. Okay, so we're also going to talk about something called congruency. And this is a symbol that you should be very familiar with. That means that something is equal. Something like this with the little squiggly on top means that something is congruent. So congruency and equality are very similar, but lengths are equal and segments would be congruent. So their measures would be equal, but if we're just talking about the segments without bringing in the actual length or the value, then we could say that they are congruent. So we would say 4 is equal to 4, but we would say line segment AB is congruent to line segment AB. If you do not write the line on top of the AB, then technically it is representing the measure, so it would be representing 4. So you could say AB is equal to CD. That would mean the measure of AB is equal to the measure of CD, but with the line on top of it, you would need to have a line over your equal sign to make it a congruent statement. So measures are equal and angles are congruent. So the names of angles would be congruent. So these measures, which we would say the measure of angle ABC is equal to the measure of angle DEF, and angle with that little m in front of it, that means measure, angle ABC is congruent to angle DEF. So, if it has a measure, and it's talking about the length, then you use an equal sign. If we are just talking about the segments or the angles, then it would be congruency. Okay, so the definition of congruent statements is pretty much our first definition that we're talking about. This is a biconditional statement, like a definition. Definitions are always biconditional. And what it says is if two segments are congruent if and only if they have the same measure. So segments are congruent if they have the same measure. This is how it is spelled out. That could be representing the definition, and this is how we will be abbreviating this unit. Then we have the definition of congruent angles, which is very similar. That two angles are congruent if and only if they have the same measure. So angles are congruent if and only if they have the same measure. Their measures are equal. Okay, so vocab. It says write and draw a picture for each pair of angles in your vocab book. Well, you don't have a vocab book, at least not yet, so just maybe star these pages. You need to know these definitions. We will be having a quiz on them next time. So supplementary angles are two angles that add to be 180 degrees. So the measure angle 1 plus the measure angle 2 equals 180. Complementary angles are two angles that add to be 90 degrees. So the measure angle 3 plus the measure angle 4 would be equal to 90 degrees. Adjacent angles are any two angles that share a side. So they are next to each other and they share a common side. A linear pair is any two adjacent angles that form a line. So they create a line because they're adjacent, they're right next to each other. Vertical angles happen when two lines intersect. Vertical angles are the non-adjacent angles. So this angle and this angle, angle G and angle H, are not adjacent. They are not next to, they do not share a side, so those are called vertical angles. There will be a quiz on these next time. Mark that in your notes. Go home and memorize these definitions. Use flashcards, whatever you need to do. Okay, yeah, so a couple little problems with that is so angle A and B are supplementary, that's the information that is given, and they give us the measure of angle A, and we want to find the measure of angle B. We would simply just do 180 minus 37, because we know supplementary means that they add to 180 degrees, which would give us that our angle measure would be 143 degrees. So that is equal to the measure of angle B. So if these angles are complementary, find the measures of the angles. If you want to pause this right now and take a few minutes, well, a minute or so, and figure this out, that would be great. So complementary means they're equal to 90 degrees. So we're not finding the angles, we're finding the value of x. So x is approximately 24.3 degrees. And in this case, x would be equal to approximately exactly 23.5 degrees. If you're talking about degrees, make sure you put a degree symbol. Okay, this is what there will also be a quiz on next time, and those are these definitions that you have been using your whole mathematical life probably. Hopefully you've seen them before, but these are just properties. Properties are definitions that we accept to be true. So the addition property means that if A is equal to B and we add the same amount onto each of those, they're still equal. Subtraction is the same idea. Multiplication, also the same idea. If we multiply a number by the same thing, so if we multiply A by C and B by C, A times C is still equal to B times C. The reflexive property. So I'm going to highlight these three. You definitely want to know these. For any real number, A is equal to A. Reflexive, I would also add this. This kind of helps me remember the three of them. So R, S, T, 1, 2, 3. So R has one term in it. A real number equals real number. Symmetric property means that if A equals B, then B equals A. So you have two things. You have an A and a B, but you're just switching them. So that would be symmetric. And then the transitive property, you have three things. So if A equals B and B equals C, then you know that A has to also equal C. So it's kind of similar to the law of syllogism that we talked about with logic. And then The substitution property says that if A equals B, then A can be substituted for B in any equation or expression. A lot of times, transitive property and substitution property are interchangeable when we'll use them, but that's what that would be by definition. Okay, so what property is being used here? Of G equals H and H equals 2, then G equals 2, I would say transitive. If you put substitution, like I said, you can argue it either way. If you want to pause right now and try the rest of these, that would be a good idea. If x plus 3 equals 5, then x is equal to 2. This would be subtraction property because you're subtracting 3 from both sides. Uh, 35 equals 35. I'm dealing with one term. That would be reflexive. RST 1, 2, 3. And if x equals b plus 3, then a times x plus f would be equal to a times b plus 3, which you're replacing or substituting in for x, plus f. So that would be substitution. Okay. So, a postulate, it says recall because we're assuming that you learned that before. Postulate means to assume without proof or is self-evident. So we're going to have a bunch of postulates and definitions and theorems that we are going to come up with this unit that you are going to need to know. So the linear pair postulate says that if two angles form a linear pair, then the angles are supplementary. The converse of that is also true, making it a biconditional statement. Segment addition postulate says that if point B is on AC, and in between points A and C, then A plus B, or AB plus BC equals AC. So that's saying that this plus this equals the entire thing. Angle addition postulate, same idea. That all it's saying is the measure of this plus the measure of this would be equal to the entire angle measure. So using the postulates from the previous page, if AB equals 3 and BC equals 5, what is AC? Well, this is 3, this is 5. AC would be equal to 8. If we solve for x here, if the measure of angle DCA, so DCA is the entire angle, is 50 degrees, then we would know that it is equal to 2x plus 10 plus 3x minus 5. So I just solved that equation. So I'd have 5x plus 5. So 45 equals 5x. So x would be equal to 9. And lastly, a transversal is a line that intersects two or more lines. And this is kind of prep for next time what we're going to do. So corresponding angles, when we have two lines, so a transversal, this would be our transversal, and it is cutting through two or more lines. Corresponding angles are angles that are in the same position. So if it's like on the right side and of your transversal and the left of one of your lines, this angle would also be to the left of the line and on the right side of our angle. So corresponding angles would be something like that pair. There are like four pairs of corresponding angles in that. There are going to be 4 pairs of all of these. So with alternate interior angles, that means that it's on the inside of the two lines and alternating sides of the transversal. So those would be alternate interior angles. Alternate exterior angles are on the outside of the two lines that alternate on the side of the transversal. Same side exterior would be on the same side, and same side interior would be on the inside. So we'll get to really more of this later. 6-1 homework is due next time.